Alright, first let's take a look at how to install the plugin. First, after we've downloaded the add-on file, just drag the add-in zip file into Blender. Just click the OK button and the installation will complete. Or we can open the Preferences menu here, click here, and then select Install from your disk. And then manually select the downloaded plugin file to install. When we open the interface, we'll find there are various settings. We can set these up in advance. First, the professional version includes a mobile notification feature. This feature is implemented using both Bokeh and the NTFI service. You need to download Bokeh or NTFI on your phone. Bokeh supports iOS devices, while NTFI supports Android devices. You can choose based on the model of your mobile phone. Once you've set it up, for Bokeh, simply copy and enter this string of the URL address from your phone here. For NTFY, switch to this tab here. By default, it automatically uses the public network to establish a connection, so you don't need to set up your own server. All you need to do is enter the topic here. Into your phone's subscription. Then it will receive notifications when your render is complete. From here, we can simply click the button to generate our results. It will generate based on your host name and generate an entirely unique string of code. You can choose to utilize this specific string or transfer this entire discussion topic to your own server. Enter your own server here and fill in the token. It will also work normally. This is the setting for automatic naming during rendering. You can manually input and add these tokens yourself, or you can choose to directly modify the value of this specific parameter manually. If you add a token, it will automatically add an underscore. And then these variable names, it can recognize the current file and the current scene. Next, let's enter the scene, and I'll give a practical demonstration of this plugin's specific features. First, after we've installed the plugin, our plugin panel will appear here on the right in the N panel. They're arranged in this order with a total of 6 modules. First, at the very top, we see the render module. Here we have render image. The render module here includes rendering images, and you can switch here to render a single image at a time, or render a sequence, a series of images. Here you can choose the engine, whether you use Cycles or Eevee. There's a batch switch here, and from this menu we can simply enable batch rendering right here. We'll talk about that in a moment. Next, we see our camera list, which I think is a very important feature. But in Blender, it doesn't come with this feature natively, and I think it's extremely important. First, you can click Add Camera here to add a camera. But I think the most important feature, the automatic camera renaming system orders cameras in the scene by sequence number. For example, clicking Add Camera now adds a camera named 006. Click Add Camera again, it adds a camera named 007. Let's see. In addition to the changes here, I have successfully updated the file name. It is now named according to the latest file name. Of course, do we need to manually change it? No, we just need to select all the cameras in front and then click Rename, and it will automatically update to our latest file name. It's very convenient. There are some preset keywords like this, which you can set manually. If we open the settings here, you can manually set the camera's renaming format. There are some presets available, and you can also manually enter text yourself. Both options are possible. Additionally, in this section, in addition to this comprehensive camera management system, there is also an independent camera resolution feature. The built-in resolution is actually for the entire file globally, but in reality, many of us often encounter a variety of different output requirements. Sometimes you might need to output for a specific mobile device, or sometimes you might need to accommodate both mobile and desktop formats. Or if you have some commercial business needs that require a wide range of multiple output formats at once, making changes like this would be very troublesome. ShotStack has also integrated an entirely independent camera resolution feature. We can see that each camera has its own independent resolution. Simply switching cameras won't help. Automatically unify your previously set resolutions into a single format. You are free to choose the resolution for each camera as you like, and it can also consistently preserve this independence when transitioning between various camera angles, which makes managing outputs much more convenient for us. There's no need to add different scenes. different renders, or different view layers. It just makes everything significantly more convenient. Another incredibly valuable feature is capturing the preview views, allowing you to generate views from all your cameras with just one simple click of a button and display them all together on a single page. It will automatically capture the visual viewports of all the cameras and save them in your render folder. At this point, we can go ahead and click on Show Previews, and it will automatically display all the captured images right here on the screen for you. This makes it convenient for us to manage our shots. When dealing with large scenes and things start to lag, I think this feature is extremely useful. It also allows you to compare different shots, so you can view the overall composition in a unified and consistent way. Because for structuring and organizing the entirety of the narrative, it is incredibly helpful. In addition to displaying all the shots at once, you also have the convenient option to choose to display just a single preview. Simply click right here to view the captured image for each individual shot in the sequence. Furthermore, if you want, we can click this specific button to switch between the different cameras available in the system. At the same time, we can also rename each camera individually. Below are some basic camera parameters. There are some preset resolutions available here under the resolution section. You can choose whichever you like. And then in the resolution section, we have a vertical screen button. Once enabled, it switches to a vertical screen mode. It will recognize your selected resolution. By default, the resolution is set to landscape. Once enabled, it will switch to portrait mode. Camera name. On the right side, there's a DOF, depth of field, toggle switch. You can manually turn on DOF, or you can simply enable it right here now. You can simply click once to activate DOF. The shortcut key Ctrl+F allows us to focus on something, for example, specifically a person. At this point, we set the 3D cursor onto the person, and then use Ctrl+F to add a focus object for your camera at the position of the 3D cursor. Then the 3D cursor comes with this kind of built-in track 2 constraint, which then will be securely attached to your camera. Then you will be able to, it's turned off by default. You can manually turn it on or off to decide whether this focus object should follow your camera or not. Now let's take a look at this custom aperture shape. Now let's take a look at the function for custom aperture shapes. If you set the number of sides, it becomes a polygon with that many sides. If you use 0, it's a circle. This is Blender. You can also adjust its aspect ratio and rotation. So how can we make the scene more realistic? How can you make your renderings more realistic and give them more of a cinematic feel? Here we have a custom aperture shape. Let's turn it on. After checking the box, you'll see that nothing happens. We need to click on it and then select the texture. Click on it and then choose a texture. If you have the Pro version, it comes with 32 plus 1, a total of 33 textures. The standard version comes with 8 basic shape textures. Then we can choose the one we like. That is to say, a dispersion texture like this one. You can see that in our case, within this kind of bokeh effect, there appear some very delicate and lovely light spots. At the same time, since we are using physical principles, creating a plane in front of the camera and then using pinhole imaging. As a result, we are directly affected by this effect, which is influenced by the aperture and focal length. At this point, we need to manually fit it again. After we adjust the focal length or aperture, you can see that the shape of the light spots has become problematic. We simply click on it once, and it will automatically adjust and adapt to your current focal length and aperture, achieving a very beautiful bokeh effect. We can also choose some unique and interesting shapes such as stars. You can see it creates a very beautiful and bright star effect. It really makes for some lovely and very beautiful stars. And a very beautiful heart-shaped blur like this, we can take a screenshot to compare. We can see that this is what it looks like when using a custom aperture. As you can see, after we incorporate a custom aperture, the entire shape becomes significantly more manageable and controllable, and more customizable. You can use any shape you like, and at the same time, it can provide a much more delicate and refined result. With a much more realistic and high-quality rendering effect like this, it makes the scene feel significantly more lifelike, bringing it much closer to the visual quality that a real camera would capture. To some extent, it adds a variety of subtle and natural details to the image. Simultaneously, we notice that after utilizing this specific kind of shape, because it is based on physical simulation, it will inevitably affect the amount of incoming light. Consequently, under the exact same lighting intensity, and with the scene being equally bright, the amount of light entering will definitely be affected. Therefore, when we use it, we need to remember to use the exposure compensation below to fine-tune it, make slight adjustments, and carefully adjust the overall exposure back to a standard balanced level. The amount of incoming light is primarily controlled by the size of the shape, for example, how much of this square frame our shape occupies. The larger we make it, the larger the area of the shape, the larger the area of the shape we use, the greater the amount of incoming light, the less it will be affected. If we use a relatively small one, for example, if we use this star shape, the area is very small. You can see that compared to the one we just used, after applying exposure compensation, compared to the new type we just used without exposure compensation, its exposure is actually quite close. So we need to use more exposure compensation to increase the overall brightness. Besides using the built-in aperture shape library of the plugin, you can also easily design your own customized aperture shapes. You can create an image with a black square background just like the one shown here, and then simply draw the exact shape you want right in the center. Next, open and import the shape you created by dragging it into this folder. Then click refresh, then it will appear right here in this list. Another very important feature is the safe frame. Actually, Blender comes with its own safe frame as well. You can find it situated right here, but it is significantly restricted by the view layer, and its display effect is quite poor. As we can see, after enabling it, I think this kind of safe frame doesn't really work well. That is the reason why. We have created a brand new safe frame for your needs. After selecting the camera, go to the bottom and turn on Save Frame to enable the Save Frame switch. Then let's turn these off first. First, let's turn off the view layer. If we add one now, you'll see nothing happens. We just need to drag it a bit to get it fully activated. By default, what we add is a safe frame. There's also a center point. All these features are integrated into this safe frame. You can freely change it into whatever shape you want. First, there's this distance here. We can adjust the distance from the border to the safe frame. And you can also enable it so it becomes an extended safe frame. We can also choose freely between solid or even dashed lines and change its color or adjust the opacity. All these functions can be easily modified and adjusted within this safe frame. I think it's incredibly helpful and convenient. This not only saves you from having to learn unnecessary extra things, but also gives you better customization options. You can accomplish all of these tasks with incredible convenience, right from this highly intuitive and user-friendly menu. At the same time, you can also incorporate several different safe frames. First, after we've added a safe frame like this, we can add another one and just drag it a bit as before. You can add a title safe frame, an action safe frame, and then enter 0.33 to create a 1/3 line. You can even add another safe frame. Let's change it to a center point. Now we have a center point as well. This way, each safe frame's properties can be optimized, with each safe frame having its own independent properties. This allows the entire frame and the setup of each safe frame to reach the most comfortable state for you. This way our creative efficiency will be much higher. At the same time, these properties also support copying. We don't have to reset these things every time we create a new camera. We can copy the settings from the previous camera. First, we can see that 006 doesn't have a safe frame. Let's select it, then look at 005. Neither 005 nor 006 has a safe frame. We need to copy it from 007. So first we select 05, then 06. 07, in the outline view, the one you select first, is the item currently highlighted. Then we press Shift to select again, then press Ctrl to select 007 again. making it the main highlighted one. This is the same logic as copying in Blender. The currently highlighted object will have its specific properties copied to the yellow object. Its properties will be copied onto the orange one, so we go ahead and click on copy. Now we can see that these two cameras both have the exact same identical save frame. Similarly, this specific copy setting is currently available for use in both of the DARF and resolution menus. Here's another very powerful feature. Now, let's talk about light linking. I spent a very long time meticulously adjusting and testing its logic before finally creating this feature. I have been thinking about exactly what kind of form it should take to follow the camera. When switching between cameras, in what specific way should the lights be configured and set up? In the end, I created this feature. It allows you to bind a light or a light group to a camera. But at the same time, you don't have to set up a separate light group for every single camera, which would be very hard to manage. You can have several cameras share one light group, or have each camera use a different light group. It all depends on your specific needs. First, after selecting the camera, we still need to enable this feature. You can see that currently there is no collection. To get started with this setup, the very first step you will need to take is to navigate your cursor to the interface and then perform a deliberate click on the specific button intended for adding a brand new collection into your current workspace. You can also open it in the viewport or turn it off. You can also delete it here. First, let's just add a point light. Next, we see a very important feature here, which is light linking. This is also a toggle available for each camera. Let's turn it on. As you can clearly observe right here, there is no light collection happening. Let's manually add a light collection. As you can see, a new collection like this one appears right here. Now we simply click this add button and it will automatically add a bright light just like this one at the position of our 3D cursor. So what exactly does it do? Our stunning light collection, the purpose of light linking is to bind a collection or a specific group of lights directly to the active camera. So when we switch cameras, it will automatically switch the lights as well. This way we can light each shot separately, because often when we change angles, different lighting actually produces different effects. For example, here we have a rim light like this, and a light that's slightly to the side like this. But if we change the angle, it will turn into a light like this. But we don't want this kind of lighting, so what should we do? First, let's create and add a brand new collection. Next, we are going to add it here once more. We also want to add another rim light into the scene as well. After adding it, we give it this type of cinematic lighting. You can see that we now have two light sources at the same time. But these two lights are not exactly what we want right now, because we're lighting for a single camera angle. So how do we achieve this? When we turn on and enable the light linking feature, a drop-down menu will become visible right behind the camera. Currently, the specific camera we want to use is currently assigned to Collection 2. So, after we go ahead and select it, it will turn off Collection 1. Let's switch to 003. Switch to 003. We use Collection 1, then 003. We'll exclusively use the lighting elements from Collection 1. 001 will only use the lights from Collection 2. But when we operate like this at this point, by doing it this way, we can light up every single shot individually. Of course, you can also copy this kind of lighting directly to another shot, then make adjustments, or you can light a single shot individually. This way, each shot has room for optimization, and the lighting for each shot will be very easy to manage. You no longer need to create different scenes or different sequences and then manually turn collections on and off. Nor do you have to wait for each one to finish rendering before switching. This makes things much more convenient. It greatly improves the efficiency of your entire workflow. But does this necessarily mean we need to create a lighting collection for each individual camera? Of course not. Back when I was actively testing and carefully building this brand new feature, I also considered a lot of different possibilities. I wanted to make it truly seamless to use so that it wouldn't require anything overly complicated. For example, you wouldn't need to set up a separate light for every shot, or have to duplicate them. In this section, we can apply the same light for every shot in the sequence. or choose to use different lights depending on your requirements. That is, if the lighting setups are quite similar, or if the camera angles are similar, you can use the same lighting setup. For different angles, you can light them individually using different lights. It all depends on your specific needs. It's not so troublesome that you have to light every single shot separately. For a large number of people who need to generate detailed renders from multiple angles within the same scene, this is extremely convenient. In my opinion, I believe this feature is incredibly useful, because when I'm actually creating scenes and carefully making animations for different shots, I really feel this point. I think it's a very troublesome thing. And that is exactly the reason why I developed this specific workflow. And at the same time, if there are a lot of lights, how do we manage all of them? So we go ahead and create numerous collections. Let's reset things here. So whenever we're confronted with a scene, if we have many cameras and have created many light collections, so how do we organize and manage these elements? First, we can duplicate and distribute similar lights into various collections. At the same time, there's also a feature that allows us to link colors. We can individually incorporate these linked colors and then establish a direct connection for the lights in our collections to a specific target color. Consequently, the lights will automatically change to match that color. The key is to link the light groups with the cameras, and then the next important step is to link the various colors directly with the lights. Only by doing it in this specific way can we truly achieve the greatest possible degree of creative freedom, allowing us to manage all the lights very well. Right here in this selection menu, we are going to choose the exact color that we want to link up. Click on this specific link button, and it will link us to this color. At the same time, we can choose other colors to link as well. Manually click the link button. This ensures that all our colors are linked. Let's turn it off first and take a look. You can see that every single color we've linked can be used to directly and easily modify the lights from this color. You can see that you can efficiently batch control the colors here as well. This is the complete functionality of the light linking feature. Next, I'm going to introduce a very important feature for us in the end: batch rendering. Before that, let me first introduce the render and output presets. First, go to the render panel. In the render panel, in this setting, which is the sampling section here, we can clearly see a preview of the preset like this. Here, we can easily create and add a new preset for the current parameters. And here you can delete a preset. We can manually click on the saved presets to switch between them, allowing you to switch your render parameters with one click. At the same time, we also have output presets. The operation is the same as with the render presets. From here, we can configure the specific format shown below, and then simply click the Add button. Then you can switch with one click here as well. Whether you want a quick preview or the final output, or an animation preview, all of these can be accomplished with one-click operations like this. Why am I introducing this feature? This is primarily because when we activate our batch rendering function, we can add a new shot right here. After adding a shot, we can then manually select the specific rendering camera here. Here we have a presets option. You can use the toggle to manually enable presets and make a selection. We can manually enable the preset toggle to select the preset for this shot, the preset required for this particular shot. Instead of being limited by the overall preset, it can override the settings of the overall preset. You can select presets individually for each shot. Now let me introduce the entire batch rendering feature. First, here you can choose whether to enable rendering for this shot in the current batch. Here, you can select the camera for the current scene. Here you can enable rendering. Here you can click to expand the options. Here you can directly open the output folder. Then you can copy or delete. Here you can just manually select the specific scenes you want to render. You can manually define these settings. Manually set the duration of the render. Manually set the frame range for rendering. As we can see right here. Let's first start by creating a new scene. Now we can see the new scene we've just created. Since it's a fully complete copy, it will have a serial number tucked away inside. A new serial number. If we switch back to the very first original scene, this unique identification serial number, in the shot section, we can easily switch over to a completely different scene in the shot settings menu. it will automatically read the camera from the other scene. You can set it manually like this. You can also render cameras from different scenes at the same time. If you create a shot 2 and use scene 1, then you can also render the content of scene 1. When working across scenes, besides cross-scene rendering, in the Pro version, you can also manually select distributed GPU rendering for all your complex projects. First, let's open the GPU device settings. You can choose to use all GPUs by default, or manually specify which GPU to use. With distributed rendering like this, you might be aware of this information. When you use multiple GPUs for rendering, if you use all GPUs at once, then in Blender, the graphics cards may experience some performance loss. When 2 or more graphics cards render the same frame because their communication efficiency is limited, there will be a certain amount of performance loss. That's why, in a wide variety of cases, multiple GPUs need to use distributed rendering, which means assigning different GPUs or manually specifying GPUs to handle different rendering tasks, so as much as possible to maximize the efficiency of the graphics cards. If you assign different GPUs to different shots, then they will render synchronously in command line mode, which means rendering at the same time. After turning on the command line rendering switch, once we click render, this will automatically close Blender, and a rendering window like this will pop up. First, there is a primary monitor window like this, and then a separate rendering window for each individual shot. We can clearly see them reading the various files on the left side just like this. And you can keep an eye on the rendering progress right over here. At the same time, here you have the completed rendered files, as well as the start time and the progress of every individual shot. Because when opening a Blender file, since when we open a Blender file, the viewport takes up a large portion of the GPU memory, sometimes several gigabytes of VRAM. If you have a very large amount of RAM, then you don't need to worry too much. But even when I use 24 gigabytes of RAM, sometimes there still isn't enough RAM, and there can still be a shortage of RAM, forcing you to use system memory instead. That will significantly reduce your GPU's rendering efficiency. So when we're doing this kind of rendering, it's best to close Blender's interface itself and turn off the viewport and use command line rendering instead. That way we have more space for rendering. When rendering from the command line, we can also pause the rendering or stop the rendering process. If we press P, we can see both of these tasks have been paused. Pressing P again will resume one of the tasks. We can see that after the rendering is finished, it will display this kind of information. You can see the start time of the rendering, as well as the end time of the rendering, and the time taken for each shot, and the average frame time for each shot. After it's done with distributed rendering, it renders simultaneously. You can see the total rendering time, as well as the average time per frame. After it's finished, if you have enabled mobile notifications, you will receive a phone notification that also contains rendering information, as well as information for each shot.